Good evening. Uh, okay, so let us continue with where we left off last class. So we were in facility layout, right? Facility location and layout. We have done two problems, illustration 11 and 12. So we were starting illustration 13. Okay. So this is illustration 13, page number 57. Okay, so this is also similar to the previous problem where you have 6 departments D1, D2, D3, D4, D5 and D6. Okay. And we are given the frequency, right? The traffic movement between these departments. Okay. So you can see the frequency in page number 58. There's a table given, right? Now the question is, the hospital wants to find an optimum layout. Okay. Okay. So here, similar to the previous problem, we will, maintain a table for the highest number of, to determine the highest number of frequencies between the departments. Okay. Yeah. So let me just erase this as a department. Yeah. D1. Okay. So let us. Okay. So now we will see D1 to D2. So as per the table, so D1 to D2 is 10 and D2 to D1 is 8, right? So the total number of transport between these two, the frequency will be 18. Okay. Similarly, D1 D3 and D3 D1, 20 plus 10, right? That will be 30. D1 D4, it is 0 plus 0. So there is no movement between these two departments. D5 and D1, it is 5 plus 15, that is 20. D1 D6, it is 6 plus 0, so that is 6. So understood how we are getting these values, right? Yeah. Similarly, we'll fill between the other departments also. So D2 and D3. D2 D3 is 6 plus 6 plus 6, right? 12. D4 D2 and D4, it is 10 plus 25, so 35. D5 D2, 0 plus 10, that is 10. D6 and D2, it is 2 plus 6, that is 8. Let us move to D3. So D3 will be, D3 and D4 is 20. 20 plus 5, 25. 7 plus D5 and D3, so 7 plus 1, right, that is 8. D6 and D3, sorry, हाँ हाँ ठीक है. तो आप टेबल देखेंगे तो let us this table, right. 2, 3, 4, 5 and 6. Okay. 1, 2, 3, 4, 5 and 6. Okay, so we'll just copy the table first. Okay, 10, 20, 0, 5, 6, 8, 6, 10, 0 and 2. Okay, 10, 6, 20, 7 and 8. 0, 25, 5, 10 and 3. 15, 6, 1, 0, 23 and 4, 6. This is the data given. Okay, yeah. So now what we are trying to do is we are trying to see what is the frequency between two departments, those two unique departments. Okay, so if you see the movement between D1 and D2, okay, the movement between D1 and D2, so from D1 to D2 10 times there's a movement, and from D2 to D1 this is 8 times movement, right. So now we want to, as I told you, we are determining the number of movement between two departments. Okay, so now if you look at this, so from D1 to D2 we have got 10 plus 8, 10 plus 8. Okay, so similarly from D1 to D3, so D1 to D3 it is 20 plus, you have to check this value here in the table, 10. Okay, so that is what we are doing here, right? Understood? Yeah. So horizontal and vertical between the departments we are summing up. We were D6 and D3. This will be 3 plus, so what was this, D6 and D3, right? 8 plus 0. Sorry. 8 plus 0, so 8. Now for D4, 10 plus 20 is 30. D6 and D4, 3 plus 3, right? D6 and D4 is 3 plus 3, right? This is 6. So there's a mistake in the book. So he is given 7. It is 6. Similarly, D6 and D5, it is 6 plus 4. That is 10. Okay. So this is our frequency matrix. Okay. Okay. Now here we know the initial setup, but we will try to determine what is the most optimum setup, right? So here we can take a look and we can just examine what is the highest number of frequency, and if what two departments if we club, there will be the minimum distance, right? So minimum distance would be 1 because we can place them adjacent to each other, right? So we can just rank. So this is the highest. So we can see that D4 and D2. This, if we place them adjacent to each other, this will be the this will have the least cost, right? Then we have 230s, right? So these two have a value of 30. Okay. So D3 and D1 and D5 and D4, right? Okay. So this is the highest, and we can see the next is 25. We can, this is third, we can see, and the next is this D1, D2. Okay. So based on this, we can say we can place the we can place the distance with the highest frequency adjacent to each other, so that we will have to make an efficient facility, so that the distance is minimum and maximum weightage is given to the highest number of frequencies, right? So if suppose, so we can see D4, it is repeating here because it's having two highest with D5 and D2. So we can probably place D4 with D5 and D2, right? So now this will actually reduce the distance between these two to 1. So this distance is 1, right? And now we can see D5 is, so what adjacent we can place to these. Okay. So we can see D4 and D3, right? D4 and D3 has the third highest number of frequency. So probably we can put D3 here. Okay. And again, so there's a 20 here. Okay, so this is 3, 4 and probably 5th. Okay. That is suppose the frequency. So we can see D5 and D1. D5 and D1 we can put here, and that will also solve our D3 and D1. So this setup is solving two problems. So the higher, so this is adjacent, and then the next D5 and D1, this is also adjacent, right? So this might be more efficient. So now we have only one left. So D2 with D6. So this setup might have the least cost. You can calculate the cost of this setup as a homework. Okay. So here you will have, so the distances, right, how to calculate. So if you want D5 to D6, how much will that be? 1, 2 and 3, right? So D5 and D3 will be 1, 2. So you have to multiply that distance with the frequency. Okay. and then you can find the cost. So this is a method you have to follow. This is mostly a trial and error method, but to logically approach this method, we will first come about with the frequencies, and then we will try to club the adjacent pairs based on the highest number of frequency, right? So for the existing setup, you find the total cost. So we have done that in the previous problem, right? You must be remembering how we have done it. So we will multiply the distance with the frequency. Okay. So you find for the initial setup and for this setup, the final setup. And if you look at the solution in the book, the solution which he has given, he has also given some arrangement. Okay, so that is not equal to this arrangement, that is different. You can find the cost for the book solution also. Okay, you can find these three and then you tell me in the next class. Okay, you give me the total cost for all these three setups, right? Okay, that's your homework. Okay. So let's move on to the next chapter. We are in 2.4. Resource aggregate planning. Okay. Okay, before moving to resource aggregate planning, planning is of three types. So production planning, is of three types. This is based on the time range, right? We have seen this in the first class. This is based on the time period. Okay. This is on a time period. So the first one is long-term planning. One is medium-term plan, right? And the last one is short-term planning. Okay. So what is long-term planning? So in long-term planning, what will we analyze? So long-term planning is done for decisions like what new products should we launch, okay, and how should we increase the capacity of the facility or the factory. So long-term capacity decisions. So maybe 1 year down the line we want to double our capacity, right? So decisions like this. So you want to expand it into a new geography, right? You want to expand it into, you want to enter into new marketplaces, right? So these decisions are taken in the long-term planning, right? So this is greater than 1 year. We are looking at an outlook that is in the long term, that is greater than 1 year. Okay, and short-term planning. So short-term planning is, it is like, so tomorrow you have to deliver a unit, 100 units, okay, and you have manufactured say 80 or say 90. Okay, so for the rest remaining 20 units, you have to allocate capacity, manpower. You have to give them shifts to the work. So if somebody of your workforce is on leave, so you have to find additional resource, or alternative resource to do his job. So this is a short-term planning. So this is very minimal. So the next order, or the next lot batch production, that. But medium-term planning is 3 to 1 year. Okay. So medium-term planning will say, suppose the annual demand, which we have been talking about, the annual forecast. So suppose we have to, deliver units of 1 lakh this year. Okay. So now we have a capacity of, with the current workflow and with the current manpower, we probably can only do 90,000. Right. So medium-term planning, we will look at the possible methods to bridge this gap. Okay, to bridge this gap. This is called resource aggregate planning. So resource aggregate planning is the same as medium-term planning or intermediate planning, right? It can be even reverse also. Okay, so you have to deliver 80,000, and with the current setup, you will be manufacturing 90,000 units. So you do not want to carry the 10,000 inventory, because carrying inventory also incurs costs. Right. So you want to adjust, you want to match the annual demand. So you can reduce the number of hours, or you can reduce, the manpower you can divert him into some other product. So things like that. You can reduce the overtime, and then you can bring down the production too, so that your inventory cost doesn't go up. So this kind of a planning is called resource aggregate planning. Okay. Okay, so let us look at the strategies. Strategies of aggregate planning. Okay, so these are also called pure strategies. So in the problems, he says solve using pure strategies. So it is the same, right? First one is vary the size of workforce. Second one is vary the hours worked. Next one is vary inventory levels. The last one is subcontracting. Okay, so coming to the strategies of aggregate planning, the first one is where is the size of the workforce. So depending on your demand, for the next 1 year, so you increase and decrease your workforce. Okay, according to this strategy, you increase or decrease your workforce with respect to the demand. So what do you mean by increase or decrease your workforce? You hire or you fire people, right? So based on your demand, you hire or you fire people. So suddenly your demand increases, you hire people and to meet the demand, to meet your demand for that period. And once you fulfill that, again if your demand goes down, you fire people. So this this process also, hiring and firing people also has costs associated to it, because if you have to recruit, that will again you will have to incur cost, and if you have to fire people also, again you will have to incur cost, right? Because varying your size of your worker, you will have to recruit, your HR will be coming into picture, again firing them, so you cannot just fire. So firing also, maybe you have to give them a 3 months of a package or 3 months of a salary before you have to fire. So this is the first strategy is varying the size of the workforce with respect to the demand. Second one is varying the hours worked. So in this strategy, so the workforce will remain same. So the number will not change, but based on the demand, you will increase and decrease your hours worked, right? So in peak, probably they will work for 10 hours plus if you have high demand, right? And if you have low demand, they will work for 6 hours. 6 hours. So that kind of an adjustment is done in this strategy. Okay. And third strategy is varying your inventory levels. Okay. So in this strategy, what happens is, suppose, say 12 months you have, we are looking at 7 months. Okay. And you have a demand of say 700 for these 7 months. Okay. And your capacity is like 100 per month. Okay. But your demand is, it is not uniform. Probably it is 60 here, then 80, then 150, then 140, then probably 70, and so on, and it is 700. Okay. And you can produce 100 per month. So you will have to plan in such a way 100 units per month can be produced. So you have to plan in such a way that your inventory will suffice your demand, and there's no change in the workforce. So workforce will remain constant. So you may probably produce 100 each month. You keep it constant. Okay. And then, so what happens? Now here you will have 40 inventory, right? So you'll have inventory carrying cost. Okay. So you'll have to store your inventory for the demand. So the demand can come the next month or 3 months later or 4 months later, but your excess of inventory is stored. Okay. So this inventory carrying cost and inventory cost will be part of your production. So this is varying the inventory levels to meet the demand. Okay. And the last one is subcontracting. So in this, you will be producing at a fixed rate. Okay, and so the lowest amount, so suppose 70 is the lowest demand or 60 is the demand. So you will be producing only 60, so you will not carry any inventory, right? In this strategy. Okay, so you will produce 60, and in the second month you need to sell 20, right? So 20 you will you will give it to a vendor, right? So he will produce and give it to you, and you will fulfill the demand, right? So this is subcontracting, where you will not store the inventory, right? The additional demand will be subcontracted to a third party. Okay. So these are the 4 pure strategies of aggregate planning. Now let us look at a problem. Illustration 14. Page number 63. Okay. So here he says, ABC company has developed a forecast for the group of items that has the following demand pattern. Okay. So he is looking at 8 quarters. So he has given the data for 8 quarters, and he has given the demand for each quarter, right? Excuse me. Yeah, he has given the demand for each quarter. Okay. So he has given the demand for 8 quarters, and he has given the demand for each quarter, right? Excuse me. Yeah, he has given the demand for each quarter. Yeah. He has given the demand for each quarter. Okay. He has given the demand for each quarter. What is his question? His question is, the firm estimates that it costs 150 per unit to increase production rate and 200 per unit to decrease the production rate. And he says 50 per unit per quarter to carry the items in the inventory and 100 per unit if subcontracted. Compare the cost of pure strategies. Okay. So he has given us a demand. Okay. He has given us cost of increase of production, that is 150 per unit. Cost of decrease of production, okay, that is 200 per unit, right? And he has given carrying cost. Carrying cost is 50 per unit, and subcontracting cost. Okay, this is given as 100 per unit. Right. He has now asked us compare the cost of the pure strategies. So we know what our pure strategy is, right? These four are our pure strategies. Vary the size of the workforce, vary the hours worked, inventory levels, and subcontracting. Okay. So he has not given any hours work data, right? So this is not given in the problem. He has given us, he has given us carrying cost for the inventory. He has given us subcontract cost, and he has given us the cost for increase and decrease of production. So that is increase and decrease of your workforce. Okay. So let us proceed with solving the problem. In the first strategy, this is the first strategy, that is varying workforce. Okay. So your quarter 1, 2, 3, 4, 5, 6, 7, and 8. Okay. You have your demand. Okay. Now it is 270, 220, 470, 670, 450, 270, 200, and 370. Okay. So let us calculate what is the cost if we follow this strategy. Okay. He has given us cost of increase of production is 150 per unit, and cost of decrease of production is 200 per unit. Okay. So for okay. So let us calculate for increase. So increase and then for decrease here. Okay. So we start off with 270. So let us say our initial production rate is 270. Okay. So as we start off with 270, there are no costs. So now from 270 we are going to 220 in the next quarter. So this is decreased by 50 units. Right. So we are being given, so how much would that cost? So this is decrease, that is 50 units into 200 per unit. Right. This is our cost of decrease, cost of reduction of our production. Right. Now from 220 we are going to 470. Right. So that is how many units? 250 units. So 250. So now this is our base level. Okay. So we will calculate from the previous level, not from the top, right? Because we have already reached 220, we have decreased our production, and now we are increasing it from 220, right? So this is 250 into 150. Now we are again increasing 200 units. So this is 200 into 150. Now we are decreasing it by 120 units. Correct. So that is 120 into 200. Now again we are increasing it by 280, is it? No, 200, 180, 150. We are decreasing it by 70, increasing it by 170. Okay. So this is our cost if we follow our first strategy of varying workforce. Okay, so if we multiply this, and we will get a total of 1,97,000. Okay, so as part of our first strategy, the total cost is 1,97,000 for varying the workforce. Okay, so this is our pure strategy number 1. So second is varying the time, which is not given. So now we have been given the inventory, varying inventory levels. Okay. Okay. So let us take the table once again. So quarter 1, 2, 3, 4, 5, 6, 7, 8. We have a demand. Okay. Yeah. Demand is 270, 220, 470, 670, 450, 270, 200, and 370. Okay, this is your demand. Let us see a cumulative demand. So cumulative is nothing but we have to just sum the total demand of the previous period. So this will be 270. This is month 1. So this will be 270 plus 220, right? So that is 490, 960. I'll just take the value 1630, 2080, 2350, 2550, and 2920. Okay. So in varying inventory levels, as we have seen, what will we do? I might have erased it. Okay. So in varying inventory level, we will have a production constant. Okay, we will have one level of production for the whole quarters, and then we will just carry the inventory so that we can fulfill our demand at a later point of time from the carried inventory. Okay. So okay. So here the annual demand is 2920. So this cumulative demand is nothing but it is the summation of all the demands from the previous quarter, right? So this is 270 plus 220 is 490. Now 490 plus 470 is 960. So that is how you calculate the cumulative demand. So your total demand is 2920 for the 8 quarters. So you will have to produce 2920 divided by 8. Which will be 365 units. Okay. So production, this will be 365 throughout all the quarters. Okay. 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 Now this is a varying inventory level, right? So whatever we produce, we should be able to fulfill the demand. Okay, so that means that means, see, we cannot directly start from zero, and then we cannot hope that whatever stock we are carrying forward will fulfill the future demand, right? So that is not possible. So there should be, we have to calculate what is the initial inventory level, so that we can we can fulfill the stock. So for that we will have to determine the initial inventory, right? So let us see where we are having the least number of, where we are going negative in our closing balance, so that we can determine that much of an inventory we have to have, so that we can fulfill the order. Correct. So we will do cumulative production minus cumulative demand. Okay. So 365 minus 270. This is 95. Okay. Now this is, here it will be 365 into 2 minus 490. Right. So that is how you will have to calculate cumulative production minus cumulative demand. Okay. So if you see here, so we can see that in quarter number 5, okay, in quarter number 5, we are having a negative of minus 255. So that means if you start at 365, if you keep the inventory at 0 and you start producing 355 units from the first quarter, so you will not, with the inventory which you have left, you will not be able to fulfill the orders from quarter 4, 5 and 6. Right. So what we have to do, we have to maintain this is the highest minus, right? So we have to maintain this level in the initial balance. So in the first quarter itself, you will have an opening inventory of 255. Okay. Only then will you be able to fulfill the orders. You will be able to fulfill the demand. Understood this point? It is clear, right? Online? Neha, did you understand?
Yes, sir.
Yeah. Okay. So now we know that the initial inventory is 255. So now we will get inventory at period end. Okay. This will be 255 plus 95, right? Understood? So 255 plus 95. So that is 350, 495, 390, 85, 0. See, now because we have maintained 255 at the start of the period, here we were able to fulfill the order with our inventory. Correct. Here we have 95, 260 and 255. So this is called equilibrium. So what happens in equilibrium is the inventory which you have maintained in the starting will also appear in the end. That is right, correct? Because here you have produced 2920 units. You have a demand of 2920 units and you have produced 2920 units. So that is completed and you are left with whatever you had in the beginning. Correct. So this is logically it will come. So this is called equilibrium. Okay. This is called equilibrium. So in all the varying inventory level problems, you will have to assume that we are at equilibrium. Okay. Okay. Now he has given us carrying cost per unit, right? Yeah, carrying cost per unit is rupees 50. Okay. So what is the carrying cost? Carrying cost is the inventory at your end period. So this into 50. So you will have to do each period into 50 and you will get the carrying cost. Okay. So you can check. So he says it comes to 96,500. You can check his math. I have copied it from the book. Okay. So in my second strategy, the cost comes to 96,500. Okay. Now let us move to my third pure strategy, that is subcontracting. Okay. Okay. Can I copy this? I cannot copy, right? Okay. Okay. Fine. No issue. So let us quickly do it again. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So again, let us take down the demand. 270, 220, 470, 670, 450, 270, 200 and 370. Okay. In subcontracting, we will not carry over the inventory. Okay. So we will not carry the inventory to the next period, and whatever additional demand we have, we will subcontract it. Okay. So if I should not carry over the inventory, So I have to match, I have to decide how much I have to produce, right? So if you see, the least is 200. Okay. So I have to produce 200, right? Otherwise, what will happen? Suppose if I produce 270, right? I will have 50 units left over here, which is again in my inventory, so I cannot do that. So I have to produce whatever is my least. So my production is 200 units. So this is my production. So I will be producing 200 units for all the 8 quarters. Okay. So so I am producing 1600 units and my demand is 2920 units, right? Which we have seen. So how many more units do we need? So it is 2920 minus 1600. That comes to 1320. So 1320 units are to be subcontracted. Okay. So 1320 units are to be subcontracted. So that is, and he has given us a price, right? For subcontracting, he says 100 per unit. So we will buy it from the subcontractor and then we will fulfill our demand. So it is 1320 into 100. That will be 1,32,000. So as part of my pure strategy number 3, I am going to incur a cost of 1,32,000. Understood? So these are the 3 strategies which we are following. So in the first one, we are hiring and firing people. We are varying the workforce. We have got a cost of 197 for that. And the second one, we are producing at an average rate and we are fulfilling the demand by keeping the inventory. We are keeping the inventory and we are using the inventory to bridge the gap between our production and our demand. Correct? And in the third process, we are subcontracting. So we are producing at a minimum level and whatever we have additional demand, we are going to give it to a subcontractor and we are going to purchase it from him. Okay? So out of this 3 strategy, we will go for strategy number 2, that is varying inventory levels. Okay? Yeah. Now let us take a look at the next problem. It is a similar problem. It is a very slight variation of it. Okay. So let us solve illustration number 15. Yeah. So here similarly we have a firm. A firm has developed the following forecast for an item which has demand influenced by seasonal factors. Okay. So this does not have a constant demand, it is varying seasonally. Okay, and here we can see that the production days are also given, so the production days are also not constant. Okay, so production days are also varying, right? So he has given 1 year and he has given forecast for each month and production days of each month. Okay, so this is a big question. So he is saying, firstly, prepare a chart showing the daily demand requirements. So daily demand requirements, he says, so that is month wise. Okay, so for Jan, if you see, you have a demand of 220 units and you have a production days of 22, right? Production days. So he asks you what is the demand per day. So demand per day. That is 220 divided by 22 comes to 10 units. Okay. So similarly for all the other months, Feb, March, April, May, June, July, August up to December, right? You can do that. Okay. So that is your daily demand requirements. So if you see, so from Feb onwards you have 5, 10, 18, right? That is your daily demand requirement. Okay. Second, he says determine the production rate required to meet the average demand, right? So production rate to meet the average demand means how much you have to produce, so you have to meet your demand, right? So that will be your total demand by total number of days, correct? That will give you how much you have to produce per day to meet your demand. Okay, so total demand is 3500 and your total number of days is 250, so that will be 14 units per day. Okay. Excuse me. Yeah. Okay. Then okay, problem C says determine the monthly inventory balance required to follow a plan with constant workforce, no idle time or overtime, no back order, no use of subcontractor, or no capacity adjustment. What does that mean? This is nothing but varying inventory level, right? So he says you will have to adjust your production, your inventory balance in such a way so you have to meet your demand. So this is nothing but varying inventory level. Okay, so you will have to adjust your demand with varying your inventory level. So it is the same problem, we will solve it. Yeah. Okay, so we will have to do it the same way. Cumulative demand and production will be 14 into the number of producing days. Okay, we will produce at an average production rate, right? So let us do that. I will need more space actually. So month Jan, Feb, March, April, May, June, July, August, September, October, November and December. Okay. right? Demand 220, 90, 210, 396, 616, 700, 378, 220, 200, 115, 95 and 260. Okay, so we will go with the cumulative demand. Can someone quickly tell, or is it given here in the book? We do not have the cumulative demand, right? It is there. No, that is for the total. I want cumulative demand like this. Yeah. Let us calculate quickly. Okay, 220 here plus 90 is 310 plus 210, 520. Yeah, please tell me. Huh? 916. Okay, it is there. Okay. Oh yeah. 916 1532 2232 2610 2830 3030 3145 3240 and 3500. Okay, and now we will go with production. So we are producing at a rate of 14, right? Average is 14 and we have the number of days. So let us keep 14. It is 308, 252, 294, 308, 308, 280, 294, 308, 280, 322, 266 and 280. Okay, now let us take cumulative production as well. So why we are doing this? We are doing this so that we can come up with what would be the initial inventory. Correct. This is 308, 560, 854, 1162, 1470, 1750, 2044, 2352, 2632, 2954, 3220, 3500. Okay. Yeah. So now what is the next step? Now we are going to do cumulative production minus cumulative demand. Okay, and we will check which has the highest negative value. Okay, so 88, 250, 334, 246, minus 62, minus 482, minus 566, yeah, minus 478, minus 398, minus 191, minus 20, and 0. Okay. So this is your cumulative production minus cumulative demand. So here you can see this is your, in the month of July you will be facing the most shortage. So you will have to have an opening balance of 566 units in your month 1. Only then you will be able to fulfill your demand, right? So you are producing the same as the demand, and you will have to have an opening balance of 566. Okay. Yeah. So now what's his question here? He says, determine the monthly inventory balance required to follow a plan, right? So your monthly inventory will be 88 plus 566, right? It will be that way. So it will be that way for the whole year. So that will be your monthly inventory. So you have 654. So this thing which he has given in the last column, you will end up with 566 here. Okay. Okay. So now the next question is, the firm has decided that to follow a plan of meeting the demand by varying the size of the workforce strategy. Okay, put result in hiring and layoff cost at 12,000. If the unit cost is 100 each to produce, carrying cost per year are 20%. The average inventory and storage cost based upon the maximum inventory are 0.9 per unit. Which plan results in the lower cost? Okay, so he has given you 2 scenarios here. Okay, so the first scenario is varying workforce, and he has already given you that the cost for hiring and firing is 12,000 for the whole year, right? So this is one which he has already given you. Okay, and the second thing he says is, second is varying inventory, which we have already done in the previous step, but we have not calculated the cost. We have just calculated the inventory at the end of each period, right? Now we are supposed to calculate the cost. Now he has given that carrying cost is 20% of the average inventory value and storage costs are okay. So the value of inventory here would be additional value is carrying cost plus, storage cost. That will be your inventory cost. Okay, and storage cost, he says it is 0.9 per unit upon maximum inventory level. Okay, so if you go back to the previous, so you can see where you will get the maximum inventory level. So you might get the maximum inventory level over here, right? Oh no, this is a minus value, I'm sorry. 334 here, right? Plus 566 would be 900. Okay, so this is your maximum inventory level. Okay, so this is 0.9 into 0.9 per unit, right? Into 900. Okay, this is your storage cost, right? And the carrying cost is the average value of the inventory. So here you will have to calculate the average value of the inventory. Okay, the average value of the inventory, and then you would get 460. You might check his math. Okay, he says 460, and that is 20% of your production cost, right, which he has given. Average inventory balance is nothing but your sum of all of this. So plus 566, you will get an end balance, right, divided by 12. That will be your average value of inventory. You can try that out. Let's see if it's matching. Yeah, so 460, correct. So 460 into 20% of 100, that will be 20. Okay. So this comes out to 9,200 plus 810, that is 10,010 rupees. Okay, so in varying inventory method, we have got 10,010 additional cost, and this is 12,000. So this plan is more feasible. Okay, yeah. Let us complete this problem. We will not stop it in between. So if it extends for 10 minutes, that should be fine, right? Yeah. Now the next part, he says, suppose the firm wishes to investigate two other plans. So this is done up to here. So we are done up to point number D. Now coming to E, he says, suppose the firm wishes to investigate two other plans. Okay. A third plan is to produce at a rate of 10 units per day and subcontract the additional requirements at a delivered cost of 107 per unit. Any accumulated inventory is carried forward at a 20% carrying cost. Right, okay. Then the fourth plan is to okay, so this is our plan number 1. Right, so this is varying workforce which he has given, and this is our plan number 2. This is nothing but varied inventory. Okay, so now plan number 3, he says he will produce at 10 per unit. So we are producing at 14 per day, correct? Now he says he will produce at 10 per day, and so at 10 per day he cannot meet the demand. So he says for the remaining he will subcontract. So it is a mix of varying inventory and subcontracting. Okay. Yeah. So, and he has given us the carrying cost and also the subcontract cost. So that is our third plan. The fourth plan is to produce at 10 per day and use overtime to meet additional requirement at a premium of 10 per unit. Okay. So accumulated inventory gain is again carried forward at 20% cost. Okay. So in the difference between plan 3 and plan 4 is, so in plan 3 he will produce at 10 per day, okay, and then this plus he will subcontract. Okay, so this is plan 3, and plan 4 is he will produce at 10 per day and then what does he say, and he will use overtime at a premium of 10. So his cost of production is 100, right? So he will add another 10. In overtime it is 110. For overtime it is 110. Okay, and in subcontracting his cost of production is 100 if he manufactures it on its own, but in subcontracting it is 107. So this is the only difference between plan 3 and plan 4, right? Okay, so we can see that in plan 3 and plan 4 the costs are same except for this, right? And the production will also be same, so except for this. So plan 3 is definitely going to be cheaper by 3 rupees per unit. Okay, so now let's calculate as per plan 3. Okay. Okay, first we will calculate how many units have to be subcontracted. Okay, so we know the annual demand. So annual demand is nothing but 3500, right? And the total number of producing days, we know it is 25. Okay, so now total production would be 25 into 10, correct? Because he says he'll produce at 10 units per day. Oh sorry, 250, sorry, yeah, 250 days. So 250 days and 10, so that is 2500. So the number of units for subcontracting will be nothing but, number of units for subcontracting will be 1000, right? 3500 minus 2500, this 1000. Okay, so the cost would be 1000 into 7, right? That is 70,000. This is the additional cost. Now we will have to calculate the inventory cost. Okay, so inventory cost, how are we going to calculate? Okay, okay, so in equilibrium, what we have seen in equilibrium, what happens, the closing balance will be our opening balance, right? So the inventory in December, whatever the inventory in December is, that will be your opening balance in Jan, correct? So here if you see, your production and your demand. Okay, so let us keep demand first and then production later. So demand and production, right? So 220, 180, sorry, this is 90, 90, 210, 396, 616, 700, 378, 220, 200, 115, 95 and 260. And if you see production at 10 per, this will be 220, 180, 210, 220, 220, 200, 210, miss somewhere, 220, 210, 22, excuse me, yeah, 210, 220, 220, 200, 210, just 220, 200, 230, 190 and 200. Okay, so if we see inventory change, so if we assume it is 0, right, this is 0, there will be 90 left in the inventory. 0 minus 176 minus 396 minus 500, 168, 0, 0, 115, 95 and minus 60. Okay, so if you see here, you will have, if you sum these three, so here it is 0, right? Till here you are getting a 0 inventory change. So if you sum, you will get 150. So 150 is going to be left in your inventory at the end of the year. So, yeah. Yeah. So 150 should be your opening balance. Correct? Okay. So let us quickly calculate. Opening balance this is your demand, production and closing balance. Okay, so 150, 220, 220, 150, 150, 180, 90, 240, 240, 210, 210, 240, April, 240, 220, 39. Did I just reverse? Okay, let us keep this as produced. This is demand. Okay, because we'll have to plus and then minus, right? Yeah, 396 and 64. So you're understanding, right? Opening balance plus production minus demand equal to closing balance. Okay. Coming to May, 64. So opening balance will be the balance of the previous month. I'm just carrying that forward. Okay. 64, 220, 616. So here you will have a minus 332. So you will not have any closing balance. Now why you are then, if you're not having closing balance, how you are going to fulfill? Because we are also subcontracting, right? So we will get the units from subcontracting. Okay. So your closing balance will be 0, 0, 210, say 220. This is 200, right? For June, yeah, 200, 700 minus 500. So that is again 0. It's 210, say 220. June, it is 200. July, 210. August, it is 220. September, it is 200. $378, 200, 15, 8, so 220. October opening balance is 0, 210. So we end up with what we have started. You make a note of this, then you can analyze. It is just simple. I have just taken the closing balance, and if it is negative, it will be 0 because there is no closing balance, production, demand, and subtracted it. Okay. So now your carrying cost would be this closing balance. You will have to sum all the closing balance into, and he says, he has given the carrying cost, right? So 20% of the inventory cost of the years must be carried to the. So he says 20% into production cost, no extra storage cost, by per month. So it is 1.6. So it is 100 into 20% divided by 12. It is 1.67. Okay. So your carrying cost would be 1.67 into the sum of the the sum of your closing balances. Can we quickly calculate that? Give me 1 minute. 150 plus 240 plus 64 plus 115 plus 150 into 1.6. Is it 210, right? Yeah, plus 150. This comes to 1169. Okay. So how much are we getting? 1169 into 1.67. 1952. Okay. So it is 1952 plus, we have calculated the subcontracting 70,000, right? So in plan 3 it is 1952 plus 7,000. 7 is it? Oh sorry, yeah, 7,000. So that will come to 8952. Yeah, this is for plan 3, and for plan 4 it is 10,000 plus 1952. Right, that is the only difference. That would come to 11952. Okay. So I suggest once you get time, you do the problems on your own for better understanding. Okay. So otherwise you will remember everything in class, but tomorrow you will forget it because I've experienced it. So you kindly do yeah, so you have to do the problems on your own once, and if you get any doubts, then you can ask me, then that will become clear for you. Okay, so please do these problems at home also. Only 2 problems, but these are lengthy because there are many sub parts in the problem. Okay, so this is, we will stop it today. I've already exceeded my time. Okay, thank you. So Neha, any doubts? Okay, so do the problems on your own. Okay, study at home. Yeah, thank you. We'll close here.